The world you once knew has quietly slipped away, replaced by a reality that feels familiar, yet functions on an entirely different set of physics. Imagine for a moment that time is no longer a linear path, but a fabric that can be folded, compressed, and reshaped by an intelligence we created. We are living through the great integration, where the spectacles of the past have become the infrastructure of the present. Before we dive into the depths of how 2026 has rewritten the rules of human existence, I invite you to join this journey of discovery. Subscribe to the channel now and let us explore the silent revolution together, because the future does not wait for those who are merely watching. We begin at the foundation of human growth, the way we learn, which has undergone a radical transformation. AI tutors are no longer simple machines that tell you if a math problem is right or wrong. They have become cartographers of the human mind. These systems engage in what we call cognition mapping, tracking the subtle hesitations in your voice or the way your cursor lingers over a specific sentence. They recognize the recurring mistakes that reveal a fundamental misunderstanding of a concept, rather than a simple lapse in memory. In real classrooms today, these tutors adapt their teaching style in real time, moving from visual explanations to Socratic questioning the moment they detect a mental block. The goal is no longer to finish a lesson faster, but to make the learning deeper and more resilient. We are seeing years of academic friction, the kind that used to discourage students for generations, compressed into a few weeks of breakthrough moments. As we move from the mind to the screen, we witness the birth of synthetic media with true continuity. In the early days of AI video, the images were beautiful but fleeting, lacking the consistency required for true storytelling. Today, in 2026, a character born in the first frame of a film will maintain the same facial structure, the same vocal timbre, and the same emotional weight until the final credits. This breakthrough allows entire advertising campaigns, complex educational explainers, and even short independent films to be generated as cohesive units. Creation has shifted from the tedious control of individual frames to the high-level direction of narrative arcs and emotional themes. Production workflows that once required hundreds of specialists are now orchestrated by a single visionary with a clear direction. It is a world where the only limit to cinematic expression is the depth of the creator's imagination. While we create, we must also protect, and this has led to the rise of autonomous cybersecurity systems. In a world where digital threats move at the speed of light, human intervention has become a secondary defense, too slow to catch the first wave of an attack. AI systems now act as the immune system of our global infrastructure, detecting, isolating, and neutralizing threats in a matter of seconds. Enterprises and financial institutions rely on these closed-loop defenses because even a delay of a few minutes can result in catastrophic damage. These systems do not just react, they predict, identifying vulnerabilities before they are exploited by bad actors. We have reached a point where the silent war of the internet is fought between competing algorithms, while we sleep in relative safety. The security of our personal data and national power grids now rests in the hands of guardians that never blink. This leads us to a more intimate evolution. The emergence of personal memory is that know us better than we might know ourselves. Persistent memory has moved from a technical concept to a fundamental reality of our daily lives. These systems retain our long-term preferences, the history of our professional projects, and the complex patterns of our personal lives. The barrier was never the capability of the machine, but the necessity of absolute privacy for the user. Now that these safeguards are in place, the AI has shifted from being a simple tool to becoming a long-term collaborator. It remembers the specific feedback your boss gave you 3 years ago and uses it to help you prepare for a presentation today. It is a digital extension of your own consciousness, ensuring that no insight is ever lost to the fog of time. On a global scale, high-fidelity economic and policy simulation models are quietly influencing the decisions of the powerful. These systems ingest massive amounts of real-time data, from supply chain fluctuations to shifting demographic trends to model second-order effects. They help governments and institutions anticipate the consequences of a policy change rather than guessing the outcomes based on outdated theories. These models do not make the final decisions, but they reveal the hidden cascades that a single choice might unleash upon a population. By simulating the impact of a tax change or a new environmental regulation, leaders can navigate the complexities of the modern world with a clarity that was previously impossible. It is a shift from reactive governance to proactive stewardship of our collective future. The intelligence we have built is no longer confined to data centers, as embodied robotics control brings AI into our physical reality. We are seeing the rise of vision-language action models that allow machines to understand complex instructions and adapt to the messages of the real world. This is not about the shiny humanoids of science fiction, but about practical automation that can generalize beyond a rigid script. A robot in a warehouse can now receive a vague instruction like, "Clean up the spill in aisle 4, and figure out the necessary tools and movements on its own." They are learning to navigate the physical variation of a home or a factory with the same ease that we do. This marks the end of the era where robots were restricted to cages, and the beginning of an era where they are our physical partners. In the realm of creation, coding agents have moved from writing lines of text to maintaining entire software ecosystems. Development has shifted from the act of writing to the act of supervising, where humans define the desired outcome rather than managing every keystroke. These AI agents plan complex architectures, debug across thousands of files, and run exhaustive tests without being asked. Software development has become outcome-driven, allowing a single developer to build and maintain platforms that once required entire engineering departments. This acceleration means that new ideas can be brought to life in days, not months, lowering the barrier to entry for innovators everywhere. The human role has been elevated to that of an architect of logic, while the machine handles the heavy lifting of execution. Perhaps the most profound impact is felt in scientific discovery, where AI is moving beyond solving known problems like AlphaFold to generating entirely new hypotheses. In fields like biology, chemistry, and material science, the cycles of discovery are collapsing from years of lab work to weeks of digital simulation. We are finding new alloys for better batteries and new drug compounds for rare diseases at a pace that feels like a miracle. This acceleration does not replace the scientist, it multiplies their reach, allowing them to test millions of variations in a virtual environment before ever picking up a pipette. The history of science will look at 2026 as the year we finally unlocked the secrets of the molecular world. We are no longer limited by the speed of human trial and error, but by the speed of algorithmic insight. All of these advancements are made possible by multimodal reasoning models that understand the world as it actually is. Modern AI can reason across text, images, audio, and video simultaneously, mirroring the way the human brain processes information. This capability is the foundation upon which robotics, tutoring, and autonomous agents are built. Without it, the machine is blind to the context of the world, but with it, it begins to understand the nuances of a gesture or the subtext of a spoken word. It can look at a video of a broken machine, read the manual, and listen to the engine's sound to diagnose a problem. This holistic understanding is what allows AI to step out of the digital void and into the complexity of human life. We must recognize that frontier language models are no longer the headline, they are the engine of this new world. By 2026, these models have become the invisible infrastructure upon which almost all advanced systems are built. Improvements in their reliability and reasoning abilities compound across every application, from medical diagnostics to legal research. They are the electric grid of the 21st century, providing the raw cognitive power that fuels our digital economy. We have moved past the novelty of chatting with a bot to the reality of an environment where intelligence is a utility. It is always there, always capable, and increasingly essential to the functioning of modern society. This power is being organized into AI operating systems, which serve as the orchestration layers for our digital lives. Humans now define the outcomes they want to achieve, and the operating system manages the tools, memory, and permissions required to get there. It is the end of fragmented apps and the beginning of an integrated system that functions with a singular purpose. You no longer need to switch between 10 different programs to plan a business trip and file your expenses. The system coordinates the flow of information for you. Once the coordination between different AI tools becomes reliable, the technology stops feeling like a burden and starts feeling like a natural extension of our intent. We are moving toward a world where the interface between human and machine is as seamless as a thought. The complexity of these tasks is often handled by agentic systems and AI swarms, where multiple agents collaborate like a professional team. One agent might be an expert in research, another in writing, and a third in critical review, all working together to complete a project. This mirrors the way human organizations work, but at a scale and speed that no group of people could ever match. These swarms can plan, execute, and adapt to new information under the supervision of a human lead. It allows for end-to-end project completion, where a complex goal is broken down into 1,000 small tasks and executed with precision. The power of the hive mind has been digitized, providing us with a workforce that never tires and always seeks perfection. To ensure these actions are safe and effective, AI systems now utilize world models that simulate reality internally. Before taking an action in the physical or digital world, the AI runs thousands of simulations to predict the outcome. This allows for counterfactual reasoning, where the system asks, "What if?" before committing to a path. Planning has become cheaper than failure, which dramatically reduces the mistakes made by autonomous systems in high-stakes environments. Whether it is a self-driving car navigating a busy intersection or an AI managing a global supply chain, the ability to dream the future before it happens is a vital safeguard. We are building systems that are not just smart, but wise enough to consider the consequences of their actions. This leads to the practical reality of autonomous end-to-end workflows, where entire business processes run with minimal human intervention. The breakthrough of 2026 isn't just about raw intelligence. It's about the reliability of the handoff between different stages of work. Research, drafting, coding, and reporting can now be linked together into a single, seamless pipeline. This allows organizations to operate with an efficiency that was previously unimaginable, freeing humans from the glue work of moving data from one place to another. We are seeing a shift where the human role is to provide the creative spark and the final ethical sign-off while the workflow manages itself. It is a world where productivity is no longer measured by hours spent, but by the quality of the direction provided. The most technical and perhaps most consequential shift is the rise of constrained self-improving systems. These are AI models that continuously refine their own skills through structured feedback loops and accelerated iteration. This is not the runaway intelligence of a movie, but a tightly controlled process where the machine learns to be better at a specific task every single day. Because this improvement never pauses, the progress compounds, leading to levels of expertise that surpass human capability in specialized fields. It is a quiet revolution of refinement, where the system you use today is measurably better than the one you used yesterday. This constant evolution ensures that we are always at the cutting edge of what is possible. The bottom line of this journey into 2026 is that AI has moved from spectacle to integration. The systems are quieter, more constrained, and more deeply embedded in the work that actually moves the world. We are reshaping how we learn, how we create, and how we protect our societies through a partnership with the machines we built. It is a time of immense challenge, but also of unprecedented opportunity for those willing to adapt. My lesson for you is this: in a world of accelerating intelligence, the most valuable skill you can possess is the ability to ask the right questions and set the right direction. Do not fear the automation of the task, but embrace the liberation of your own potential. As you look toward your own future, ask yourself, what is the one thing only I can contribute to this new world? How can I use these tools to solve a problem that has always felt unsolvable? The machines will handle the logic, but the heart and the purpose must always come from you. If this exploration has sparked a new perspective within you, please subscribe to the channel and join our community of forward thinkers. Thank you for walking this path with me, and I look forward to seeing how you will shape the world of 2026 and beyond. Together, we are not just observers of the future, we are its architects.